Hi, hello, vanakkam, and welcome back to another episode on your favorite Little Slack YouTube channel. I'm going to talk about the response time. You all know what is a response time is, but it's not just a number. So when we say response time, most people think of it as a single figure. That is, they might say that my API responded in like 1.2 seconds or my web page loaded in 3.8 seconds, right? But you know what? There is a catch. Yes, response time is not just one number. It's actually the sum of multiple sub times that occur between the moment a user initiates a request, which is if I initiate a request, and the moment I see the result on my screen, or the moment they see the results on their screen. So ignoring these components, which we're going to talk about, will lead to false conclusions about where your performance bottlenecks lie. So we say the response time is high. So why does it go high? What is the reason behind that? Right. So there are several components between that, and we're going to discuss that about that in detail today. So out of which the first component is the network latency, because every request starts by traveling across the network. We know that, right? So we are in the internet world and everything happens through the network. So even before your server touches the request, right, the following steps add time. The first thing is the DNS lookup, which means the client has to resolve your domain name into an IP address, right? That's the first activity. So the DNS lookup. The second item is the TCP handshake. So when you establish a reliable, like you have to establish a reliable connection between the client and the server. That's the TCP handshake. That's why you could see everywhere that there's a TCP connection, right? So that's the second thing. The third one is the TLS or SSL negotiation. So if HTTPS is used, say for example, if it is a HTTPS protocol one, which almost always we do. So encryption setup takes an additional round trip. So if you're doing a HTTPS request, it will take an additional encryption request. And then the packet travel time. So distance between the client and the server will also add the latency. For example, if the user is in India and he is accessing a US hosted service, then there is a packet travel time. Now, why does it matter? Why all these four items that we discussed so far is matters is if DNS resolution takes 400 milliseconds, that is resolving your name. It does not matter how fast your server is, the user already feels the delay. And next thing is the CDNs and the DNS optimizations and the TCP TLS tuning that can dramatically reduce this part of the response time. Secondly, the server processing time. So far I think I understood, okay, and I can understand that there are a lot of things that is revolving in your mind, but the second thing we'll have to know, that's the server processing time. So once the request arrives at your server, the heavy lifting begins, the actual work begins, because this includes the first thing, that is the queue wait time. Because if the threads or the connections are busy, then the request wait in a queue. This is what I used to say all the time to all the people, like check the queue wait time, because that's what it creates a lot of time in the queue. And then the CPU processing, the business logic execution, the encryption, the decryption, the compression, all these ends. Yes, execution, encryption, decryption, and the compression, everything has to be taken care of with the CPU processing. And then the memory access, so the cache hit versus the misses, the garbage collection passes. And next comes the database queries. So when I talk about database queries, we have to talk about the database round trips, the query execution, the joins, what type of joins do you use, how effectively are they, and then the indexing. Yeah, most of us would have talked about the indexing a lot of time, right? So, and then the external dependency, so calls to any microservices, calls to any APIs or any third-party services. So why all these matters? The DB, the external dependencies on our CPU, memory, because testers often see and the users often say the server is slow, but they don't dig deeper, because a 3-second server response could actually be 500 milliseconds of CPU plus 2.5 seconds of database query, which means your optimization focus should now shift to the database and not the CPU, because your CPU is just 500 milliseconds and your database takes 2.5 milliseconds, right? And then the third part is the client side rendering time, because even if the server responds quickly, the user still waits until the browser or the application renders the result. So what are the key steps here? The first thing, yes, the DOM processing. I was talking about this at several places, the DOM processing, because building and parsing the HTML structure is what the DOM processing does. Yes. And then the second thing is the JavaScript execution, because running the scripts, applying the logic, fetching any additional resources are all part of the JavaScript execution. And next comes the style and the layout calculation. So if you're applying any CSS rules, and if you're applying any, if you're recalculating any layout. So when I say layout, the front end UI performance testers I have even discussed about that in a separate video on that playlist, so you can watch that. And next comes the painting and compositing, so actually drawing pixels on the screen. So all these are the front end performance, the UI performance testing related topics. So why all these matters, why all these front end matters? Because a backend may return the results in 200 milliseconds, but if JavaScript takes 2 seconds to execute, then user experience the app as a slow. Yes, so tools like Lighthouse, sitespeed.io or browser dev tools will help to uncover all these. So now the problem with ignoring the breakdown. So if you are ignoring all these, okay, you still believe that the response time is 5 seconds and I do not want to understand the breakdown. What happens is many testers and the team stops it. So the API takes 2 seconds to respond. Yes, we know that. But which part of that 2 second is the culprit? Is that the database, the UI front end, the DOM, the layout? What is that? The network latency. So if it is a network latency, you have to optimize the CDN. You have to use edge servers. You have to reduce the DNS lookup. And if it is a server issue, you have to optimize the code. You have to add caching. Yes, so to fix all these, yes. And then you have to tune the databases. If it is in the server side, you have to optimize the code, add caching, tune database. Now you know what to do if it is a server side issue. If it is a client side issue, you have to reduce the JavaScript bloating, the lazy loading assets. You have to fix all those. So without all these breakdown, the client side breakdown, the server side breakdown, so without all these breakdown, the performance tuning will just become like a guessing game. You do not know what to do, right? So you will be like just doing, okay, it can be a CPU or it can be memory or it can be a CD. Even the CDN and DNS also are there behind the screen, but we do not know that, right? So there are some tools. I mean, like there are a lot of tools I would say, but there are some tools which I can talk about to you shortly to break it down. So luckily, many tools can expose these subtimes. So Dynatrace, AppDynamics, New Relic, these show the server side breakdown with the code level tracing. That's the main advantage of it, because you can drill down up to the last function code. And then you have the sitespeed.io, the web page test, the Lighthouse, which show you the front end rendering and network times. I have even I'm taking a big playlist on Lighthouse with Puppeteer as well, so please do watch that if you want to know about the front end issues. And then the hair files, so the browser generated files that detail each step of the request timing, and that's, I would say, a big resource for you to understand how the response goes down. And then the bottom line here is response time is not just how long it took, it's a chain of events. We know, so far we talked about DNS, CDN, server, client and everything, right? It's a chain of events across network, server and client. So performance tester who analyze this breakdown can move from the system is slow, so they won't anymore say the system is slow, or instead they should say that the slowness is due to the DB queries or the latency is caused by the TLS negotiation. So that's the difference between a good tester, a good performance tester, and a great performance engineer. Let's see who you